Okay, so now we'll see some examples on the limit by using the quiz theorem. Okay, so the problem is that using the quiz theorem we have to prove this limit x tends to 0. So we'll solve this. Okay, solution 1. Okay, we know that mod of sin x is less than equal to mod x for all x greater than 0. Okay, so we are familiar with this one. So therefore what, minus sin x, minus x, not minus sin x, so minus x is less than sin x is less than x is less than x. Now limit x tends to 0, minus x is less than, limit x tends to 0, sin x is less than equal to, limit x tends to 0, x. So this is what, 0 less than equal to, limit x tends to 0, sin x is less than equal to 0. Okay, so by quiz theorem, so this is what, limit x tends to 0, sin x is equal to 0. So this is by quiz theorem. This limit is also 0. Okay, now we'll go to the second one. We know that the second one, okay, we know that 1 minus x square upon 2 is less than cos x is less than equal to 1 for all x belongs to R, or all x belongs to R. We are familiar with this one. Okay, so now see here, limit x tends to 0, 1 minus x square upon 2 is equal to 1, and this is also same as limit x tends to 0 of 1. Okay, so limit of these two functions are same. So therefore by quiz theorem, limit x tends to 0, cos x is equal to 1, So now we'll take up next one. So again we will take this. We know that okay. Now we want here 1 minus cos x upon x. We have only the cos x, so we change the sign first. If you change the sign first, then the inequality is it's changed now. This is minus 1 plus x square upon 2 is greater than cos x is greater than minus 1. Now we will add 1 now, so that we get 1 minus cos x. So this is what, x square upon 2 is greater than 1 minus cos x is greater than 0 now. Okay, we call this as 1 now. Okay, case 1, x is greater than 0. We want here 1 minus cos x upon x. So we have to divide by x. When we have to divide by x or multiply by x, so that number you have to think whether this number is positive or negative. So you are dividing means you are multiplying by 1 by x. You are multiplying by a negative number, then equality interchange. If your number is positive and if you are dividing or multiply, then equality remains as it is now. So x is positive, now your equality is as it is now. So this is what, then x by 2 greater than 1 minus cos x upon x is greater than equal to 0. Okay, so limit x tends to 0, x by 2 is same as limit x tends to 0 of 0 is same as 0. Okay, so therefore by quiz theorem, limit x tends to 0, 1 minus cos x upon x is equal to 0. Okay, so in case 1, if x is greater than 0, then this is 1. Okay, now case second. Now your x is less than 0. So if x is less than 0, we are dividing by your equality. So 1 implies that. So this is your 1 implies that. You are dividing by x and x is negative. You have to change the inequality is the reverse now here. So this is what, x by 2 and then equal to 1 minus cos x upon x less than equal to 0. Again here limit x tends to 0, x by 2 is equal to limit x tends to 0 is 0. So limit of these two functions are same. So therefore by quiz theorem, by quiz theorem, limit x tends to 0, 1 minus cos x upon x is equal to 0. So from case 1 and case 2, from case 1 and case 2, from case 1 and case 2, limit x tends to 0, 1 minus cos x upon x is equal to 0. Okay, so is over. Okay, now next. Solution of fourth one now. Okay, so we know that minus 1 less than equal to sin x less than or equal to 1. It is useless now here. It is useless because we have to divide by sin x now. If x sin x is there, then that will be work now here. So this will not work. We know that if 0 less than x less than pi by 2, then sin x less than equal to x less than equal to tan x. Okay, so this is what sin x. So this is sin x less than or equal to, we may write this as what. So this is strictly, we can write this is 1 upon sin x is greater than x is greater than 1 upon tan x. 1 upon tan x. So 1 upon tan x means what? This is the cos x upon sin x. Cos x upon sin x. Okay, we'll multiply by sin x. We'll multiply by, here there should be 1 upon x. Okay, so this will multiply by sin x. So this is 1 greater than sin x upon x is greater than 1 is greater than cos x now. This is cos x. Okay, so that is what? That is cos x is less than sin x upon x is less than 1. Okay, so now we'll take a limit now. Limit x tends to 0, cos x, this is less than equal to limit x tends to 0, sin x upon x, this is limit x tends to 0, 1. Okay, so it will be what then? It will be 1 less than equal to limit x tends to 0, sin x upon x, and this is less than equal to 1. Therefore, again by quiz theorem, limit x tends to 0, sin x upon x is 1. Okay, so I have proved this one. Next, we know that we can write now here sin of 1 by x is less than equal to 1 for all x belong to R, x not equal to 0 now. Okay, so now what we will multiply by x now? So this is minus x. So x sin 1 by x, this is less than equal to x. Okay, so limit x tends to 0. We'll write this limit x tends to 0 of x is equal to 0. Okay, so therefore by quiz theorem, or directly you can take the limit, no problem for this one. Limit x tends to 0 of minus x, limit this. Okay, so that also we can do this one. Okay, by quiz theorem, limit x tends to 0, x sin 1 by x is equal to 0. Okay, on the same line, you can prove this one also. So here only I have to write cos x now, because we know that sin x and cos x both are the bounded function. Their value lies between -1 and 1. So now we can multiply here by this. So cos of 1 by x, this is x square. Okay, so limit x tends to 0 of minus x square is same as limit x tends to 0 of x square is same Therefore, by quiz theorem, by quiz theorem, limit x tends to 0, x square cos of 1 by x is 0. Okay. So these are the very simple problems on the quiz theorem. So using next problem, using quiz theorem, evaluate limit x tends to 0, x to the power 3 by 2, x is greater than 0. If x is less than 0, then x to the power 3 by 2 does not exist. That means limit does not exist. Okay. So here we have provided to x is greater than 0. Okay. Solution. We know that x is less than x to the power half is less than 1 for all x 0 less than x less than 1. Okay. So we multiply by x, what we get? X square less than x to the power 3 by 2 is less than x. Okay. Now we'll take a limit now. Limit x tends to 0, x square, limit x tends to 0, x to the power 3 by 2, limit x tends to 0 of x. So this is 0 less than equal to limit x tends to 0, x to the power 3 by 2 is less than equal to 0. This is by quiz theorem. Limit x tends to 0, x to the power 3 by 2 is equal to 0. Okay. Now we take a next problem. Limit x tends to 0, x sine 1 by x square. X sine 1 by x square. Okay. So we know that minus 1 less than equal to sine of 1 by x square less than equal to 1. We can multiply by x now here. So minus x sine 1 by x square less than equal to x. So limit x tends to 0, minus x, limit x tends to 0, x sine 1 by x square. Whatever the sign of something, whatever this. Okay. So maybe the function of x. So here if there is multiple of x, then the problem is very easy now here. Okay. So this is what then limit x tends to 0 of x. So this is 0 less than or equal to limit x tends to 0, x sine 1 by x square is 0. Okay. Again by quiz theorem. So this is what limit x tends to 0, x sine 1 by x square is equal to 0. Okay. So if there is a root, there is no problem for root also. So if there is a root, no problem for this one. Okay. So you can multiply by root here and then root. So it will be 0. So this is also 0. This limit is exist and this is equal to 0. So here what? X is greater than 0. This is what if x is greater than 0. So I hope that you understand how to solve the problems by using the quiz theorem. Okay. So now we will stop here. Thank you.